going. Welcome, everybody. We are going to start comparing fractions today. So let's look at our learning target. I was viewing it. We'll go all the way back up. We'll go up to our learning target in a minute. I forgot. We're going to review. So I know I can't use my smartboard, but I'm going to let you look at this. I also wrote it on paper, so I'll use my document camera. But I want you to, on your paper, to go ahead and start solving these problems. We're going to warm up. We've got 27 divided by 9, 4 times 4, 234 plus 421, 412 minus 258. And then a little riddle. I have 5 sides and 5 angles. I am not a parallelogram or a quadrilateral. I am a polygon. What am I? And then one problem on rounding. Round 527 to the nearest 10 and 100. Remember, 5 and above, give it a shove. 4 and below, take it down low. So I'm going to keep that up for just a couple minutes. You guys can write it down on your paper and then we'll solve them together. I have them written on paper as well under my document camera. And actually, this is the perfect lesson today to not have the smartboard. We'll be just fine. Hi, Henrik. I see you just joined us. We are just doing our review with paper and pencil. If you can grab any paper and pencil, it doesn't matter. We are going to need that for math today. That would be great. Thanks, bud. And you can start solving these problems. Get your brain warmed up. Josh, did you have a question?
No, just I'm ready to answer.
You're so smart. All right, I'll start solving here in a minute. Let me tell Lennox. Lennox, welcome. Glad to see you. We are just warming up our math brains. So if you could get out a piece of paper and a pencil, and we'll start solving these. All right. All right, these are the same problems, just on paper. So probably similar to what you have written down. Let's go ahead, Josh, wanted to share. Do you want to go ahead and do 27 divided by 9? And tell us what you got and how.
27 divided by 9 equals 30.
How do you know? You're right. How do you know?
I used the 9 trick backwards.
Can you explain what that means? The 9's trick backwards? That's a great strategy.
So you pretty much just you just see which one. You basically do something equals 27. So I just did this and then I got 27 and I put my third finger.
Okay, so he made 27 with his fingers. So 2 fingers on the left and 7 on the right. So the 2 fingers on the left are your 10s and the 7 fingers on your right are your 1s. And that made it your third finger had to be down. So 27 divided by 9 is 3. And we also know 3 times 9 is 27. So the inverse operation helps us figure that out as well. All right, 4 times 4. Let's see. How about Miss Sunny Poe? What do you think 4 times 4 equals?
16.
You're right. How do you know?
Because I knew 4 plus 4 would be 8, and 8 plus 8 is 16.
Excellent. So you kind of used repeated addition to help you. 4 groups of 4. I like it. All right. I need a volunteer to walk me through this one. 234 plus 421. Lucas Stewart. How would I solve this? This is addition.
So 4 plus 1 is 5,
Mm-hmm.
and 3 plus 2 is 5,
Mm-hmm.
and 4 plus 2 is 6.
So
So that would be 655.
what made that one different than the problems we have been doing? Did I have to make any new groups of 10?
Yeah. No, wait.
Were any of these answers or sums greater than 9 or 10 or more?
Mm-mm.
No, so I didn't have to bring the one over to the next place value, did I? So I just did that on purpose because I want to make sure that you don't do it just to do it. If I had 238 plus 423, if I added 8 plus 3, that would be 11. I would have to make a new group. And that's what we've been doing a lot of. And then adding 1 plus 3 plus 2 makes 6, and then 2 plus 4 equals 6. The difference here is if you have 4 plus 1, it only equals 5. It's not greater than 9, not 10 or more, then I don't need to make a new group. So I just wanted to remind people that some of you were just adding a 1 for no reason. So we got to be careful that we don't do that. All right, go ahead and get a volunteer to do 412 minus 258. Max Fox, go for it.
So first what you want to do is, so you can't do 2 minus 8. You have to borrow from the 10s to make 12. And after you do that, there's a 0 in the 10s place. You need to borrow 1 from the hundreds place, and you make that 10. And then you do 12 minus 8, which equals 4. And then you do 10 minus 5, which equals 5. And then you do 3 minus 2 equals 1.
Nice. All right. Give me a thumbs up if you agree with Mr. Fox. Yeah, Robert, what do you think? Was he right? Yeah, okay. I have 5 sides and 5 angles. I am not a parallelogram or a quadrilateral. I am a polygon. What am I? Astria.
Pentagon.
Yep, pentagon. We should be getting that vocabulary now, right? I always think it looks kind of like a house. Doesn't have to look that way though. Okay, round 527 to the nearest 10 and 100. So let's start with the nearest 10. If we're looking at 527, the tens place is 20. So the number is going to be between 520 and 530. You have to look at the digit in the ones place. It's a 7. Am I going to round that to 520 or 530, Mr. Westwood? What do you think? Can you unmute, hun, so we can hear? Robert, are you okay? Can you unmute and answer the question? Are we going to round 527 to 520 or 530 if we're going to round to the nearest 10?
530.
How come? You're right. Why would 530 be the correct answer?
Because 7 is higher than 5, so it would go to the higher 10 and then to the I guess lower 10, I guess.
Yeah, that works. Great.
And
Okay.
The
So
100 would go to 500, so it's pretty much just you're doing a 10.
all right, let's look at 527 rounding to the nearest 100 this time. So if we're going to round to the nearest 100, 5 is the digit in the hundreds place. That means we're going to go between 500 and 600 would be the higher. We have to look at the digit in the tens place to see whether to round up or down. Haley Calendar, is 527 going to round to 500 or 600? What do you think?
500.
Can you explain your thinking? You're right.
Because there's 27 and 27 is closer to 500
Right.
than 600.
Yeah. It's only 2 tens away instead of 8 tens, right? So well done. And then when you're looking at the 2, you know, 4 and below, take it down low. All right, well done, you guys. So let's go ahead. I wanted to share some more of my fraction action book by Laureen Leedy. I've had some requests for that. So before we get into our actual learning target today, I'm going to read where we left off. We talked about fractions, unit fractions, and then we stopped here. So I'm going to continue with the book, and I won't finish the whole thing today, but let's read a little bit more since we have some time today. Get ready, get set. A few days later, Miss Prime turned out the lights again. Today, we will learn how to make whole sets into fractions. Please look at the screen. We are a set of 2 rectangles. I am half of the set. I am the other half. We are a set of 3 triangles. I am a third of the set. So if you see, if there's 2 in a set, 1 out of 2 is half. If there are 3 in a set, 1 out of 3 would be a third. We are a set of 4 squares. I am a fourth of the set. We are a set of 5 circles. I am a fifth of the set. Now, class, here is a set of marbles. I'll give them to you for keeps if you can figure out how to divide them equally. That reminds me, boys and girls, of the symbol of a fraction, meaning division, right? Remember when I showed you that at the beginning of the year, the line between your numerator and denominator is a division symbol. You'd better get started. Since there are 5 of us, let's try to divide the set of marbles into fifths. Maybe we could group them by color. Sadie gets blue, Faye gets yellow, I get red, Otto gets purple, and Tally gets green. Wait, the piles have to be equal. Let me try a different way. I'll give everybody a handful. Piles are still not equal. I know what to do. I'll count them out like this. 1 marble for Ginger, 1 for Sadie, 1 for me, 1 for Otto, and 1 for Faye. Keep going until all the marbles are gone. Does everyone have the same number of marbles? I have 6 marbles. I have 6 marbles too. Me too. Me too. Me too. That means we each have exactly 1/5. Congratulations, you found a way to divide the marbles equally, so you get to keep them. Time for recess. And here's your question. How many marbles were in the whole set? I want you to write it down on your paper and then raise your hand when you know the answer. There were 5 children. They each got a fifth, right? Because there was 5 of them. Remember, each person had 6 marbles when they were done dividing them. How many marbles were in the whole set? Look at your picture clues and write down your answer when you have your answer. Give me a thumbs up or raise your hand. So I'm waiting on a few people. I'm gonna give you a few minutes. Max Deesberg, do you have it yet? Paxton's got it. So we want to know how many marbles she started with. Katie's got it. Lennox has it. Good job, buddy. Sawyer, you think you know? Not yet. Get your paper and pencil, work it out. 5 people with 6 marbles each. How many marbles is that? You could count them right there and figure it out. But I want you to get the answer, okay? You got this. Get that math brain working. Finn, thumbs up. Do you have the answer? All right. Lila Maris has it. Lennox, you have had your thumb up a long time. All right, Lennox, will you unmute and share what you think the answer is?
I think the answer is 25.
Can you explain your thinking?
Yeah, because the text said we each have 1/5, and there are 5 of them, and 5 times 5 is 25.
Your thinking is spot on. I just want to point out though that 1/5 of the set was 6 marbles each. So look at your picture. Use that same thinking, but use 6 in your groups. So 5 groups of 6. What would that equal, Lennox? Do you think you know? Sawyer, what do you think?
I think it's 30.
Okay, let's go to page 32 and see if you're right. There were 30 marbles in the whole set. Nicely done. Good job. All right, we're going to read just a little more. A fair share. One Saturday at about noon, Sadie heard a loud knock at the door. Hello, Sadie. Is this a good time for us to drop in? I was just fixing lunch. Wonderful. We'll help. Let's start with a whole apple for everyone. Let's also have oranges. Oops, I can only find 2. Not enough for all 4 of us. You can cut them in half. Good. That will give us 4 halves. There they are, hard to see. So each person's got 1 whole apple and 1/2 of an orange so far. What about this watermelon? If you cut it into parts, everybody will get an equal share. Let's eat. Knock. Hi, Sadie. I hope this is a good time to visit. Well, let's see if you can see. Miss Cow is here. We only have enough to feed 4 of us. What should we do? Just give me that fruit. I'll be right back. Hi, Miss Bovine. Chop, 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 chop. Fruit salad for everyone. Oh, no, thank you. I'm not hungry. What fractions were used to make lunch? Here's your hint. There were 3 different fractions. Which fractions did they use to make lunch? At the end, she didn't use fractions. She just chopped it all up so Miss Cow could enjoy, Miss Bovine could enjoy it with them. But what fractions did she use? Raise your hand when you have it. I'm going to go back They started with a whole apple. They had some oranges. They had a watermelon. Which fractions? Lyric, do you have any idea? Do you have one fraction that they use?
I think they did 4 fractions.
Okay, but what's one of the fractions they use? Can you give me?
Thirds.
What did they cut into thirds?
Wait, sorry, fourths.
Okay.
Wait, no,
Okay, what did they cut in half?
oranges.
The oranges. So that was one fraction. Does anyone know another fraction they use for lunch? It just shows you how we use fractions in everyday life. Evie, what else did they use?
Fourths for the melons.
Fourths for the watermelon. Very good. And let's.
This is Autumn.
Yeah.
May I interrupt for just a moment? I have some friends who are chatting right now on Google Chat, and I've closed their tabs several times, and they are still chatting. So can I let those friends know that I'm going to have to call some parents or do some emails if you guys don't stop chatting during class? That is not what we're doing right now.
Thank you. Boy, that makes me so sad. I'm trying to make it fun, you guys. I really would hope that you give me your attention. So here's one we didn't get. We did get the 1/2 to slice the oranges from Lyric. And then we also got the 1/4 for the watermelon, the 1/5. Didn't think about that one. They had to divide the fruit salad, right? Into fifths because there were 5 of them, even though Ms. Bovine decided not to eat. All right, so I just wanted to share that because so many of you have asked me to do that. I'm glad you guys are enjoying that book. We are going to, let's see if I can exit that. Go back to our screen. We read part of the book. Here's our learning target for today.
Learning target. Use fraction bars and number
Somebody
lines.
needs to mute. We are going to use fraction bars and number lines to compare just unit fractions. And I'm stressing unit fractions because we will be looking at fractions that are not unit fractions tomorrow. So today is going to be much simpler than tomorrow. If you can get today's lesson, that's going to really help you as it gets more complicated. So we can solve real world math problems that involve comparing fractions. You'll be able to use fraction bars and number lines to compare fractions as well. So let me, I don't know how I got to that. Let me go back. Just want to remind you of our math vocabulary because we're going to be introducing in a couple days some new vocabulary. I want to make sure we have this down. A fraction is a number that names part of a whole or part of a set. We saw that in the book today. We looked at the marbles, right? You can have a fraction of a group or a group of rectangles or a group of circles. But we also can just have a part of a whole, like a part of a pizza or part of a cookie, or part of a fraction bar or number line. So fractions can be different. A unit fraction, that's what we're focusing on today, is a fraction whose numerator is 1. It shows only one part of a whole. The numerator is the top number in a fraction. It shows the number of equal parts counted. And the denominator is the bottom number in a fraction. That shows the total number of equal parts in the whole. Okay, so here's a quick video. I know we are going to be focusing mainly on fraction bars, but I wanted to show you this one on circles as well.
Compare the fractions. This circle has 3 equal parts. One part is shaded. 1/3 of the circle is shaded. This circle has 2 equal parts. One part is shaded. 1/2 of the circle is shaded. This circle has 4 equal parts. One part is shaded. 1/4 of the circle is shaded. The numerators of each fraction is 1. These are all unit fractions. Greater denominators create smaller unit fractions, and smaller denominators create greater unit fractions. Let's compare the fractions. 4 is greater than 3. So 1/4 is smaller than 1/3. 2 is smaller than 3. So 1/2 is greater than 1/3. Let's arrange the fractions from the greatest to the smallest. From the greatest to the smallest, the fractions are 1/2, 1/3, 1/4. Compare the fractions. This circle has 10 equal parts. One
Elena,
part is shaded.
pay attention.
1/10 of the circle is shaded. This circle has 5 equal parts. One part is shaded. 1/5 of the circle is shaded. This circle has 9 equal parts, and one part is shaded. 1/9 of the circle is shaded. All of the fractions are unit fractions. Let's compare the fractions by comparing their denominators. 5 is smaller than 9, so 1/5 is greater than 1/9. 10 is greater than 9, so 1/10 is smaller than 1/9. Let's arrange the fractions from the greatest to the smallest. From the greatest to the smallest, the fractions are 1/5, 1/9, and 1/10.
Okay. So if you have your workbook, we are going to look at page 100 or 359. I'm going to put it on the screen here. If you are in person, you obviously don't have that, so that's okay. We will, let's see if I can get rid of this. We'll look at it on the screen. And so Bird has it. That's awesome. So let's everybody turn to page 359 who has it. And if you don't, so look up here, Lucas, eyes on the screen. I want you to look at the fraction bars, and we're going to be comparing these unit fractions. All of these bars are made up of unit fractions. That means that they're one part of a whole. Their numerator is 1. So looking at the screen, what do you notice? What are some of the patterns that you see in the fraction bars? What are some of the patterns? What is happening as you go down, or just what things do you notice about these bars? Any patterns that you might see? So look at it, think about it. Abby, what do you notice?
I noticed that that the numbers are going like in a mountain shape, but there's one line in between them going straight up.
Okay, so it looks kind of like a mountain shape. That's interesting. Yeah. Anybody else have an observation or pattern? Lila Maris?
My observation and pattern is on it one whole and 1/2 are the biggest unit fractions, and my pattern is that they get smaller as the area that's in between each number, like in between each unit tiny fraction, the denominator gets bigger and the numerator stays the same.
Excellent. So the numerator is the same for all of them because they all have 1, right? And they're unit fractions. But the
Yeah.
denominator does get larger as the pieces get smaller. Great observation. Elena, what did you notice?
I noticed that it was like 1/4 and then 1/2 and then 1/3, then 1/4, then 1/5, then 1/6, then 1/7, then 1/8.
So they go, the denominators go in counting order from 1 to 8. Very
Yes.
good. Okay, anybody else have a pattern or noticing?
Sunny and Suriname and Henry.
Sunny, let's start there.
I noticed that the number on the bottom, the larger it gets, the smaller the
Fraction.
the smaller the sections get.
Excellent. Thinking about that, like we talked about it being like a Kit Kat bar. If you had to share it with more people, you would get less of the Kit Kat bar, right? The fewer people you have to share with, the larger your pieces would be. All right, then you said Suriname and then Henry. Suriname, go ahead. What did you notice?
Like when you look at them going down, it goes I think is the denominator.
Mm-hmm.
It goes 1, 2, 3, 4, 5, 6, 7, 8, 9.
I think it stops at 8. Yeah. Excellent. So it goes in counting order, the denominator. Henry, what do you notice?
That in the middle, as it gets smaller, in the middle, the lines keep disappearing, then coming back if you go really fast looking down it
Okay, I'm going to share.
in the middle.
He's talking about in the middle. I love what you're saying. That is, and I'm going to. Somebody needs to mute real quick if you could do that. That would be fabulous. If you look at what Henry's saying in the middle, notice that every other fraction bar can be divided in half. Do you see this middle line that Henry was kind of talking about? Now, I can divide my halves in half. When I get to the thirds, it does not have that line in the middle. But if I get to my fourths, look, there it is again. Fourths can actually be folded in half, right? We fold it in half, then fold it in half again to get our fourths. But not on the fifths, that doesn't work. But on the sixth, it does. We have a halfway mark. On the seventh, do we have a halfway mark? Thumbs up or down? Leo says no, you're right, Leo. But on the eighth, do we? We have another halfway mark. So I love what you're saying. Some of our lines, if you take I'm going to take the edge of this book. Sometimes our lines that are dividing our wholes into fractions line up. Sometimes some of them line up. Do all of them line up? No. Some of them line up, some of them do not. So that was a great observation. Every other fraction bar can be divided or split into 2 equal parts. Like this can be an equal part, this is an equal part. This and this, this and this and this and this. But that's only every other one. I think one of the important things that I heard is that as the denominator gets larger, the fraction gets smaller. And that's the case with unit fractions. And that's what we want to remember when comparing them. Gets smaller. And I just want you to keep thinking about dividing, sharing. So let's go ahead and use this. And on your paper, here's what I want you to write. We have 3 problems. We are going to compare using the greater Gator. Remember, the greater Gator's mouth opens to the larger fraction. If the denominator, if it's a larger denominator, means that it's actually smaller, which would be greater, 1/3 or 1/7? What do you think, Gabe? Would you rather have 1/3 of a cookie or only 1/7 of a cookie if you really like that cookie?
Third.
1/3. So when we write this, I want you to write this on your paper because I know you don't have your workbook. If you have your workbook, put it in your workbook. We're on page 359. Sawyer, show me on your paper where you've written this problem. Hold it up for me. You're going to compare 1/3 to 1/7. I want you to write it because that's good practice, right? So you would make that greater Gator's mouth open up to the larger fraction. Gators like to eat big things or a lot of something. So we want the bigger number. Let's double check Gabe's work. Let's look at our fraction bars. Go up to your third. Here is 1/3. Boop, right? This is 1/3. Is that greater than this little bit of 1/7 of the bar? Yeah, right? It is much larger. Well done, Gabe. All right, let's go on with our next 2 problems. 1/3 compared to 1/2. Which would be greater, Katie? Would you rather have half a pizza if you're really hungry and you love pizza, or only 1/3 of the pizza?
Half a pizza.
Yeah, how do you know that 1/2 is greater or 1/3 is less than 1/2? How do you know that?
Because the number is less, 2 is less than 3, so that means you just cut it in half and then you get more.
Right, but you would cut it in half. You get 2 equal parts instead of having to divide it among 3, which would make your pieces smaller. Excellent. All right, and then Sawyer, you ready? Are you writing this, Mr. Jensen? 1/6 compared to 1/7. Which would be greater? What would that greater Gator eat? 1/6 of the pie or 1/7 of the pie? Sawyer, what do you think?
6 of the pie.
Why? You're right. How do you know?
Because I forget.
Let's look at our fraction bars. Do you see where 1/6 is? Look at the size of 1/6. Look at the size of 1/7 right below it. What happens when you have to share something with more people? What happens to the piece?
You get more or less.
You get less, right? The pieces get smaller. Does anyone disagree with that or agree? I hope all thumbs are up that you agree. 1/6 is greater than 1/7 because your piece is larger because you're sharing with fewer people. All right, we're going to turn on over to this page. If you're in your workbook, it's page 360. Otherwise, get your paper ready. I want you to look at this number line. And again, let's just talk about, what do you notice? Do you see any patterns? What do you notice about the fractions on this number line? Leo, what do you see?
I see that the number line is one whole.
Excellent. Good observation. It's only one number line, right? One whole. We looked at some last week where we had more than one, greater than one. Cooper, what else do you notice on this number line? What do these fractions have in common? What do you think is different about them, Mr. Suzette? Help them out, Finn. Finn, what do you see?
None of them are equal.
Okay, they're not the same. You're right. Their denominators are different for sure. Any other observations before I start sharing some thoughts?
I got another one.
Go for it.
They're all unit fractions but one.
Excellent. Yes, these are all unit fractions. That's so important that you pointed that out. That's our learning target today. We're comparing unit fractions because the rules are different when comparing fractions, and that's something you want to remember. When it's a unit fraction, if the denominator is greater, look at this one. Everybody find 1/8 with your eyes or with your pencil. Do you notice it's further to the left than to the right? So whenever you're using a number line to compare fractions, the fraction that's further to the left is smaller than the fraction that's further to the right. So if I'm comparing 1/8 and 1/2, Astria, which one is greater, 1/8 or 1/2? If the further to the right, the greater.
1/2.
1/2, right? It's further along on that number line because one whole cookie is what you really want. I'll take a half. I really don't want only 1/8 of that cookie. What about 1/6 compared to 1/3? Max Fox, which one would be greater?
1/3.
Yeah, notice that 1/3 is further along on the number line to the right. So it's going to be greater as well. All right, before we do this next section, I want to use some cards for visuals to help you. On your paper, you are going to write which fraction you think is greater. We're going to compare, okay? I'm going to use some visuals to help you. So 1/2 or 1/4. Notice that the denominator for 1/4 is 4. The denominator for 1/2 is 2. 4 is greater than 2, but is the fraction greater? Ellie, what do you think? Which is greater?
1/2.
1/2. Excellent. Okay, let's try another one. Let's look at 1/3 and 1/4. Stand up if you think 1/3 is greater than 1/4. If you think 1/3 is greater, stand up. Stand up if you think 1/4 is greater. Like, no, 4 is more than 3, so I'd rather have 1/4 of that cookie. You might think you're being smart by knowing that 4 is greater than 3, but when you're looking at fractions, 1/4 is less than 1/3. Again, you got to picture it. You got to visualize. I'm sharing my cookie with myself and 2 other people. If I have to add another person, that's less cookie. No, I don't want that. All right, let's try another one. 1/10 and 1/12. Stand up if you think 1/12 is greater than 1/10. Ooh, good job. I don't think I stumped anybody. Stand up if you think 1/10 is greater than 1/12. Nice. You're getting the hang of it. The lower the denominator, the greater the fraction. Let's try another one. 1/8 and 1/6. Stand up if you think 1/8 is greater. Stand up if you think 1/6 is greater. You should be standing. 1/6 is greater. The lower the denominator, the greater the fraction, the fewer people you're sharing with. Okay, how about 1/5 or 1/12? 1/12. 12 sounds like a lot, but only 1/12 is not a lot. Elena, which one's greater, 1/5 or 1/12?
1/5.
1/5. Ding, 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 ding. You are right. Now let's look at it with a different visual. What about this visual? Just to give you an idea. What if we compare 1/6 to 1/3? Now on these fraction cards, the blue portion is the portion that we're comparing. That's the fraction. That's 1 out of 1, 2, 3, 4, 5, 6 equal parts. This is 1 out of 1, 2, 3 parts. Astria, which one's greater, a 6 or a 1/3?
A 1/3.
Can you see it? Can you tell that it's greater? Yes, no, maybe?
Yeah.
Excellent. All right, what about a 1/4 or an 1/8? Jensen? Which is greater? All right, Bird, which is greater, 1/4 or an 1/8? Look at it. Is that looking like more? That's only half what a 1/4 would be. Isn't 1/4 more? Yeah, 1/4 is greater than an 1/8. You can actually see it on the blue. If you look at the comparison, there's more blue on the 1/4 card than on the 1/8 card. So 1/4 is greater than 1/8. Let's look at one more. 1/6 and 1/3. Which one is greater, Finn?
One-third.
Yes, even though the denominator is smaller, the fraction is larger. All right, so we are going to quickly compare these. I want you to write these down on paper. So those of you, you're going to compare 1/3 to 1/8. First, let's write that one down first. Going to give you a few minutes to write these down. We're looking at numbers 6 through 11. These are the problems I want you to do on your paper. Go ahead and write those down.
Finish.
Once you have them written down, go ahead and solve it. Which do you think are greater? If you've done that, give me a double thumbs up. You already have that figured out. All right. Abby, I can't see your thumbs, honey. Can you get out from under the blanket? Show me what you've done. Can I see your paper? Astria's got it. Lila's working hard. Lucas is working hard. Haley's working hard. Ben is working hard. Evie's working hard. Sawyer, I don't see your pencil moving, bud. Get that pencil and paper. You got it? Hold it up and show me. Because I just see a ball being thrown. Gavin, how you doing, bud? Good? Yeah, you didn't have to write it. That's nice. All right, Paxton, what do you think 1/3 compared to 1/8 equals? Which is greater?
1/3.
The greater gator should have eaten the third. Well done. Charlie Carr, number 7, 1/4 or 1/2. Which one would be greater?
1/5.
You're so smart. Next, Cooper, 1/5 or 1/8. Which would be greater?
1/5.
Yay. Katie Waldron, number 9, 1/2 or 1/8. Which would be greater?
1/2.
Okay. Number 10, Evie, 1/4 or 1/7. Which would be greater? You're muted. Which one?
1/4.
Yay, you're making my day. And number 11, Mr. Bowers, 1/6 or 1/8. Which would be greater?
1/6.
1/6. I think you guys have got it. Now, which two unit fractions would 1/5 be between on this number line? If you look back at this number line, where would I draw 1/5, do you think? Between which two fractions, Lyric? Where would 1/5 go?
It goes between the 6 and the 4.
So between 1/6 and 1/4, I could write 1/5. Yep, you're right. All right. And think about making a fraction bar for tenths. So on the other side, we only went to 8ths, right? If I were going to make a fraction bar for tenths, like here's my whole fraction bar, and I wanted it to be in tenths, how many unit fractions would be in that fraction bar? What do you think? Gavin, how many unit fractions would be in my fraction bar if I were making a fraction bar for tenths?
9.
Well, not ninths, I want tenths. 9 lines maybe, but how many fractions? Let's see. 1/10, 1/10, 1/10, 1/10. What do you think, Gavin?
10.
Yeah, 10, right? Because there are 10 equal parts in the fraction bar, just like on our other fraction bars. For 8ths, we had 8. 1, 2, 3, 4, 5, 6, 7, 8. For 7ths, we had how many? Microphone answer. 7ths should be 7. 6 should be 6. Yeah.
7 should be 7.
So we would write that fraction 1/10, 1/10. I want to point out one other thing before we move on. Notice that the fraction bars, did anyone notice these fractions on the side? What do you notice about these fractions on the side here? They're not unit fractions, all of them. Gabe, what do you notice? We have 1/1, 2/2, 3/3, 4/4, 5/5, 6/6, 7/7, 8/8. What do you notice about that?
I noticed that first one at the bottom there's a 2, no, a 1. Then the second one there's a 2, then a 3, then a 4, then a 5.
Why do you think that's the case? What are we doing with each fraction bar? What are we dividing them into?
We're dividing them into what the number tells us.
that denominator is, right? So that denominator is telling us the number of equal parts. But notice the numerator. All the fractions in the bars are unit fractions. What is happening with the numerator? Something different. Lucas, what's happening with the numerator for each one of these fractions?
Each one is like, it goes 1, 2, 3, 4, 5, 6, 7, 8.
So it's the same as the denominator, isn't it?
Yeah.
And what do we know? If this line between the numerator and the denominator means divide, what is 1 divided by 1?
0.
How many
No,
1s
wait.
are in 1?
0.
No, 1 is 1, right? How many 2s are in 2, Haley Calendar? What's 2 divided by 2?
2.
No, that would be 4 divided by 2.
1.
1. 3 divided by 3. Gavin.
1.
1. 4 divided by 4. Anyone.
1.
5 divided by 5.
1.
1.
Divided by 6.
1.
7.
1. 1.
All over the crowd. You got it. So notice that all of those fractions, if a fraction has the same numerator and denominator, it's really one whole. This is standing for one whole. Notice it's at the end of the fraction bar. That's the whole fraction bar. I just thought that was a good teaching point. I didn't want to miss out on. All right, so we are going to let you share how you're feeling about comparing unit fractions. We went through these, we practiced. How are you feeling about comparing unit fractions? The main idea of it is that the lower the denominator, the larger the fraction. Gavin, I can't tell what that means. Are you happy? Are you sad? Are you good? Are you bad? Okay. Lucas, I'm not sure how you're feeling. Elena, I see you. Abby, I'm not sure what that is. Astria, thank you. Evie, is that a little bit of both? Kind of in the middle? Okay, Ellie's got it. Here's what your task is for today. Thank you for sharing. You have an exit ticket. Explain how you can compare unit fractions. For example, how would you compare 1/2 to 1/8? Which one is greater and how do you know? Okay, so here is where you'll find it. For my in-person learners, this is something a little different for you. Go to classwork. We are doing math. So we have a math topic, right, in our Google Classroom. Go down, you have to scroll down. It's right above homework. You should only have one lesson appearing for today. It's lesson 7.4 Tuesday. Your exit ticket is right here. Exit ticket for 7.4. You're going to answer and then you're going to submit it or turn it in. Do not try to share it. Make sure you turn it in and I will get the, turn in the assignment. I will get it and be able to grade it. Explain how you compare unit fractions. For example, how would you compare 1/2 to 1/8 and how do you know which one is greater? Okay, any questions about your task? Anybody not sure what to do before I say goodbye until mañana? I'm looking for hands. Paxton, did you have a hand up? Or a thumb down? What's a thumb down mean?
No, I don't have any questions.
Oh, okay, got it. Sorry about that. Anybody else have a question? Yeah, I'm going to stop sharing so I can see you guys better. I see, okay, now I see questions. Madison.